Hello everyone and welcome to Mark Scheme Merchant. This video will be a quick overview of radical substitution. Okay, let's dive into the topic. Alkanes are very unreactive. To make them more reactive, you can add halogens by radical substitution. As an example, we're going to use ethane and react it with chlorine to make chloroethane. Radical substitution has three steps which I have outlined here: initiation, propagation, and termination. Initiation forms radicals by homolytic fission using UV light. Each chlorine atom here will gain an electron, and therefore will have an unpaired electron. A radical is a species with an unpaired electron. It's important to remember that in our reaction mixture we will have a mixture of chlorine, ethene, and chlorine radicals. Propagation is the use of these radicals, and is where the actual substitution takes place. A radical reacts with a molecule, forming a new radical and a stable molecule. In this case, our chlorine radical will react with ethane to form HCl and this ethyl radical. That new radical can react again, so you've got a chain reaction occurring here. In the second propagation step, the ethyl radical reacts with chlorine, forming chloroethane and a chlorine radical. Termination is the process by which the radicals are removed so that the chain reaction ends. All the radicals in the mixture will need to react to form stable molecules. Let's see what radicals are available to react. We have the two chlorine radicals, which can react to make a chlorine molecule. We can react two ethyl radicals to make butane, and we can react an ethyl radical and a chlorine radical to make chloroethane. As you can see, this will form a mixture of products. In your exams, you could be asked about problems with radical substitution. The main problem with this process is that a mixture of products is formed. One reason for this is that you can have multiple termination steps, as I showed before. Another reason is that you can have further substitutions, which I have shown happening here. If you don't have a termination step, the chain reaction continues, as the radicals will continue reacting, forming products that you don't want. As you can see, we don't want this. Another reason a mixture of products forms is that substitution can happen anywhere along the carbon chain. Suppose we want to make 2-chloropropane. Let's take a look at the propagation step for this. The chlorine radical could take a hydrogen from carbon 1 of propane, leaving a radical to form on carbon 1. This would form 1-chloropropane, which is not what we want. Or, the chlorine radical could take a hydrogen from carbon 2, which leaves us with a radical on carbon 2, forming 2-chloropropane, which is the product that we wanted. And that's all there is to it. Hopefully this video was helpful. If it was, give it a like, consider subscribing so you don't miss any upcoming videos, and send this video to your peers to help them out.